Alright, in this video we're going to solve linear equations with the distributive property and with variables on both sides, but we're also going to look at some examples that have infinite solutions and an example that has no solutions. So here I've got three different equations, and we're going to start just by solving the one in the middle. This is the one that you're probably familiar with. I'm just going to try to isolate the x by using inverse operations. So I see a minus 4. I'm going to add 4 to each side, and those inverse operations are going to kind of cancel out on the left side of the equation there. Here with 5x equals 15, divide by 5 on each side, and end with the result of x equals 3. Now, that is a normal linear equation. Let's move over to our equation that's on the left. I'm going to start by distributing, and anytime I distribute, I'm going to distribute that sign in front of that coefficient. So that's going to become negative 2x, and then negative 2 times 4 is negative 8. Then I still have the plus 3x equals x minus 8. I have some like terms there and there, so I can combine those like terms since they're on the same side of the equal sign. Negative 2x plus 3x equals 1x. I can copy down my minus 8, and then I still have an x minus 8 on the other side of the equation. Now, notice what we have. Before I go any further, if I'm just kind of like paying attention as we go, I could put a 1 here if I wanted, but we have that x minus 8 equals x minus 8. Notice that this statement is going to be true no matter what x is. If I were to put in a 50 for x, 50 minus 8 is 42, and 50 minus 8 is 42. So for the x value of 50, this is a true statement. This equals this. If I were to pick an x value of 3, 3 minus 8 is negative 5, 3 minus 8 is negative 5. You'll notice that this equation will be true regardless of what value you choose to substitute in for x. That's going to be infinite solutions. If you weren't to spot that at this step and you were to keep going, let's say you try to subtract x from each side, you would get 0x minus 8 equals negative 8, or 0x is just 0. You have negative 8 equals negative 8. If you end up with a statement like this, a statement that's obviously true and x has no effect on whether or not that's true, that's another hint that you have a infinite solutions problem. Now let's move over here to the right. I'm going to solve this equation to the right. I'm going to distribute my 3, and that's going to give me 9x minus 3 equals 9x plus 7. Now notice here, if we're kind of looking and thinking as we work through this problem, you got something kind of similar here as we did here, except now it's not exactly the same. If I take some value, multiply it by 9, and then subtract 3, when is that the same as taking that same number, multiplying by 9, and then adding 7? In other words, some value minus 3 is equal to that same value plus 7. If we're thinking about this reasonably and logically, we know that's not possible. That's never going to happen. This is a no solutions. There is no value of x that would make this a true statement. Now, if you wanted to keep going, you could subtract 9x from each side, and you end up with a statement that's obviously false. Negative 3 equals 7, regardless of what x is. I mean, there's no x left in this equation. We know that negative 3 is not equal to 7. There's no value of x that would make a negative 3 equal to 7 because there's no x anywhere left in this equation. That's kind of why this is a no solution. So we have a one solution, a no solutions, and an infinite solutions equation. Once again, one last little word of wisdom. Think as you're working through these problems. If you start to see situations like that, you might know that you have a infinite solutions or a no solutions situation.